Welcome, my friends. In this video, I'm going to discuss inverse trigonometric functions. First, let's just discuss what inverse trigonometric functions help us solve for. And that is the angle theta in a trig function. So for example, if we have sine of some unknown value theta, unknown angle theta, and we are told that is equal to 1/2, an inverse trig function will help us solve for the angle theta. Now, in some cases, you don't really need an inverse trig function because some of these answers are kind of commonly known values on the unit circle. So for example, 1/2, we know that sine is the y-coordinate on the unit circle. So all you would have to do is say, well, at what angle on the unit circle is the y value 1/2? And there are actually two places on one revolution of the circle. So you can look right over here. At pi/6, the y-coordinate is 1/2. But also, so that's one answer. But also over here at 5pi/6, we are also at 1/2. Okay, so there are actually two different answers on one revolution of the circle for our angle theta. But we don't even have to restrict this to one revolution of the circle. We could go around a second time. So after we are one revolution through the circle, we would be at 2 pi radians. Or you could think of that as 12 pi/6. So that means that 13 pi/6 would be coterminal with pi/6 and would also give us a value on the unit circle of 1/2. Or the value over here, coterminal with 5 pi/6. This would be 18 pi/6, or would have to be one less than that. We would be at 17 pi/6, and this could just go on forever. There are actually an infinite number of different angles theta that could give us a y-coordinate on the unit circle of 1/2. Okay? But when we talk about inverse trig functions, we don't really want to have an infinite number of outcomes because we want a function that's going to give us just one outcome. We don't want many different outcomes. So we're only going to get one outcome, and we'll talk about exactly which outcome we will get here in a little bit. But let's just look at another example here. Say that we have sine of theta is equal to 0.51. So very similar to the last case where we had sine of theta was equal to 0.5 or 1/2. But now 0.51 is not a commonly known value on the unit circle. We don't have a y-coordinate anywhere of exactly 0.51. We can kind of guesstimate approximately where that would be. If pi/6 is 1/2, it's going to be a little bit higher than pi/6, or if we're thinking about 5 pi/6, maybe a little bit less than that to give us a little bit higher. But if we want to use an inverse trig function, it's called the inverse sine. We represent with a little -1 right here. We don't want to get multiple answers out. So we're actually going to restrict this to only certain values on the unit circle, okay? And it's different for each trig function. Specifically for sine, we're going to restrict it to the first and the fourth quadrants. So we're only thinking about the first and fourth quadrants. That means stuff over here is off limits, okay? So technically for 0.51, there would be 2 points on the unit circle. There would be one right over here. That would be about a y-coordinate of 0.51, and there would be one over here. But since the inverse sine is only quadrants 1 and 4, we're going to only consider the one over here. So it's going to be something right around here. And we'll go to a calculator here a little bit to show you how to actually type this in. But if you were to do the inverse sine of 0.51, it's going to give you, if you're in radians, about 0.54 radians, which is a tiny bit more than pi/6. Okay, so that's kind of the idea, what our inverse trig functions are doing for us. They're solving for the angle of a trigonometric function. Okay, so here we have a little statement, and it is that the inverse trigonometric functions solve for the argument, which I typically think of as the angle of a trigonometric function. So if you ever have an unknown angle that you're trying to solve for, the way to find that is going to be an inverse trig function. But these inverse trig functions are only going to give you one possible answer. As we know, the trig functions kind of are cyclical. They'll kind of repeat themselves after some amount of time. And so therefore, there's going to be many different possible angles that could be the solution. The inverse trig functions are only going to give us one possible solution on a particular interval, which we will talk about. It's a little bit different for each of the 3 primary trig functions. So we've already kind of began talking about sine. So if your goal is to solve for the angle, in this case we're calling it y, in sine, then you're going to use inverse sine. Right? The inverse function that's going to help you solve for that is going to be inverse sine, which we represent by sine with a little -1 in the middle. Okay? And the range, as we've already been talking about, is going to be between -pi/2 to pi/2. Right? There is an infinite number of angles that could satisfy this, right? Because sine is cyclical, there are many different angles that could give you any possible output, okay? We're going to restrict it when we're talking about the inverse sine to only that angle that falls between negative pi over 2 to pi over 2. And again, going back to that picture from before, negative pi over 2 would be down to the fourth quadrant down here, and then up to pi over 2 would be up here. So we're really talking about the fourth and the first quadrants. So what is the angle that gives us some particular y value in either the first or the fourth quadrant? Okay. We can also think of the domain of the inverse trig function. This is the range, the possible values you can get out. What possible values can you plug into the inverse trig function? Well, if you think about sine, maybe think about it over here, right? If x is the output of a sine function, think about the possible values for sine. Sine is the y coordinate on a unit circle. And of course, if you have a unit circle, you cannot have a y value bigger than 1 or smaller than negative 1. Or if you're thinking of the graph of sine, it never gets larger than 1 or less than negative 1. So the domain is going to be between negative 1 and 1. So if you start to plug in anything into inverse sine that's either bigger than 1 or smaller than negative 1, you're going to get an error. So like maybe you put in 1.5. Then you're basically asking your calculator to say sine of what gives me an answer of 1.5. Well, there's no value you can plug into sine to get an output of 1.5. So there would be no solution there. Okay. If we're talking about cosine, we're trying to find the angle y in cosine. It's going to be a very similar deal. You're going to use the inverse cosine. Okay, inverse cosine of your answer is going to give you the angle y. Okay, and how do we restrict this? Well, this is actually between 0 and pi. Why don't we do this? Why don't we do it the same way? Why don't we do it between negative pi over 2 and pi over 2? Well, let's look back at the picture one more time. This will hopefully make sense. If we were to restrict it between negative pi over 2 to pi over 2 for cosine, that wouldn't work because cosine is the x coordinate, right? And we would have repeats, right? So thinking about maybe down here we have 1/2, and up here we also have 1/2. So we can't restrict it to between negative pi over 2 to pi over 2 for cosine because we want to get only one outcome for each of the x values, and there are repeats if we restrict it this way. So we got to restrict it some other way. And the way we've chosen to do this, a little bit arbitrary, is just to say let's just choose the top half of the circle. That's from 0 to pi, right? So give me the x coordinate somewhere between 0 and pi, right? So inverse cosine of, let's say, 1/2. Okay, it would be like saying, where are we at 1/2 on the first top half of the circle? Well, that would be up here, right? So the answer would be pi over 3, right? Wouldn't be the one down here. No, because we're restricted between 0 and pi, okay? So inverse cosine is the range of what you can get out, anywhere from 0 to pi. And the domain, very similar to sine, is going to be between negative 1 and 1. It's kind of like asking, what can you get out of the original cosine function? What are the possible x values? Well, anywhere from negative 1 to 1. And then for tangent, we have a very similar deal. To find the angle y, you would take the inverse tangent of the result here, x. And what is the range here? Well, it's going to be very similar to sine. It's going to be from negative pi over 2 to pi over 2. But we don't actually include the values pi over 2 or negative pi over 2. Why not? Well, because those are actually undefined values for tangent, right? So we cannot include those. And the domain is going to be the original range of tangent. So what values can you get out of tangent? Well, you can get anything out from tangent. So we would have from negative infinity to infinity, right? Tangent has no bounds. If you think about the graph, it goes to infinity or to negative infinity. So we would have a domain now on our inverse function of negative infinity to infinity. All right, let's practice some inverse trig functions. So here I have the 3 inverse trig functions we're talking about, sine, cosine, and tangent. And then I've got the range of each of these functions. This might be a good time to mention that sometimes you'll see the inverse functions written as arc sine, arc cosine, and arc tangent. Just means the exact same thing. I prefer this kind of notation, inverse sine with the negative 1 there. But you will also sometimes see the arc sine, arc cosine, and arc tangent. Okay, and then we have the range of kind of where we're looking on the unit circle. So perhaps you are asked to evaluate the inverse cosine of square root 3 over 2. So what is this literally asking? This is saying cosine of what gives me a value on the unit circle, an x coordinate on the unit circle of square root 3 over 2. So where do I get square root 3 over 2? Well, you could look over here and say, oh, I get it twice. I get it down all the way over here at 11 pi over 6, and I also get it here at pi over 6, right? There are two different places where we get an x coordinate of square root 3 over 2. So which one do I choose? Well, that's where I look at the range, right? The range is from 0 to pi. So that means this one's out. We're going to have to be somewhere on the top half of the circle, which we always are for inverse cosine. So that means that the answer is going to have to be pi over 6. Pi over 6 is the angle that cosine of which gives me square root 3 over 2. That is between 0 and pi. How about inverse sine of negative square root 2 over 2? So what this is asking me is it's asking which angle gives me a y coordinate on the unit circle of negative square root 2 over 2. So again, you might say there are 2 points on one rotation of the circle. Right down here, I've got 7 pi over 4, and I've also got 5 pi over 4. So which one is it? Well, actually, it's neither, because if you look at sine, it's actually defined for negative pi over 2 to pi over 2. So we're actually kind of thinking backwards in the circle, right? So we possibly have negative angles, and that is the case here, right? So sine of not 7 pi over 4, if you think of this as a negative angle, it's going to be negative 1 pi over 4, right? Negative pi over 4 is going to give me this y coordinate of negative square root 2 over 2. So that is going to be my answer. How about the inverse tangent of square root 3? So now this is asking is where is tangent of what, basically? Tangent of what gives me the square root of 3, okay? And specifically somewhere between negative pi over 2 to pi over 2. So the same kind of range as sine, but not including the endpoints. Now hopefully you remember your unit circle for tangent. The way I think about it is tangent kind of increases as you go up the circle. So at pi over 6, we're at the square root 3 over 3. Then we're at 1 at pi over 4, and at pi over 3, we are at just square root 3. So it's going to be just square root 3. Okay. Now there is another point down here that would also be square root 3, but of course we are between negative pi over 2 and pi over 2. So where in here are we at square root 3? It's going to be pi over 3. Okay, let's try a few more problems here. So let's say we have inverse cosine of negative 1/2. So make sure you understand what this is really asking. It's saying cosine of what angle gives me a point on the unit circle of negative 1/2, an x coordinate on the unit circle of negative 1/2. Okay, but specifically we need to be between 0 and pi for cosine. Okay, so where on the top half of the circle is cosine equal to negative 1/2? Well, that would be right here at 2 pi over 3. So my answer would be 2 pi over 3. How about the inverse sine of square root 3 over 2? What angle, sine of what angle, gives me an output of square root 3 over 2, where we're between negative pi over 2 and pi over 2? Well, that would be over here at pi over 3, right? Pi over 3, sine of pi over 3 would give me square root 3 over 2. How about inverse tangent of negative square root 3 over 3? So this is saying tangent of what gives me a ratio of sine to cosine of the square root of 3 over 3, negative square root 3 over 3, really. And if you know your unit circle, you know that typically we increase as we go up the circle for tangent. So the first one over is going to be actually at square root 3 over 3, but we don't want positive, we want negative square root 3 over 3. So that's actually going to be down here at 11 pi over 6, but of course we need to think of it as the negative angle, right? The range tells us think of the negative angle, okay? So this is going to be negative pi over 6. Okay, let's try a last few examples here. So let's say we want to find the inverse cosine of 1.2. And so this is basically asking cosine of what will give me an output of 1.2. And the answer is, hopefully you're seeing this, there is nothing, right? There is no angle that can give you a cosine of which the cosine of that angle will be 1.2, right? The largest cosine can be is 1, and that would be at 0 or 2 pi or multiples of 2 pi, right? We're never going to get a cosine equal to 1.2, right? So that means there is no solution here. This is undefined, right? This comes back to the domain of inverse cosine is from negative 1 to 1, right? We can't plug anything in higher than 1 or less than negative 1 because it's nowhere to be found on the circle. Okay. What about inverse sine of 0.999? Well, this is not a commonly known angle on the unit circle, so we are going to have to use a calculator. But we can kind of estimate where this would be, right? It's asking sine of what gives me 0.999. Or where are we at 0.999 on the unit circle between right here, negative pi over 2 to pi over 2? Well, it's very close to 1, right? So it's going to be very close to pi over 2. So you would want to grab your calculator, and you would have to, first of all, make sure that you're in radians, because we're doing all of this in terms of radians. So make that, toggle that setting if you need to. And then you would find the inverse sine function, should be on most scientific calculators. So you do inverse sine, and then 0.999, and then if you press enter, you will get the inverse sine of 0.99 is 1.53, which if you type in pi over 2, you will see that that is very close to 1.53. We are just short of that. And then how about inverse tangent of 20? Is this undefined, or can we actually find this one? Well, we can actually find this one, because if you remember, the domain of inverse tangent is actually from negative infinity to infinity. This is asking tangent of what gives me 20. Or in other words, you could think of it as when you take sine and you divide by cosine, what angle would you have to have such that sine of theta would have to be 20 times as big as cosine? And so that's going to be a pretty big value in terms of, a pretty high value on the unit circle, right? We want sine to be 20 times as large as cosine, so we'd have to have a much bigger y value than an x value. Okay, so we could find inverse tangent on our calculator, press the inverse tangent function button, and then type in 20 and press enter, and we would get about 1.52, which is again very close to our pi over 2. All right, my friends, that finishes my discussion of the inverse trigonometric functions. We will be using these functions quite a bit in the next several videos to solve trigonometric equations.